Welcome to The Explainer. Today, we're going to decode clinical evidence from the absolute ground up. We're looking specifically at Lesson 2 of the incredible Evidence-Based Medicine for Techies course. Look, if you've got a technical background but zero clinical background, reading medical literature can feel, well, like reading an entirely foreign language. But what if we approached it the way a clinician actually thinks? That's what we're doing today. We're taking messy medical problems and translating them into structured, queryable data. Okay, let's dive right into this. Here's our roadmap for today. We're going to start with a vague clinical worry, introduce the PICO search schema, match our questions to study designs, execute a PubMed search, and then finally, we'll look at how to use an LLM research assistant.
So, part 1, the vague clinical worry. You know, in evidence-based medicine, absolutely everything starts with a raw, unstructured problem sitting right in front of you, the patient. The curriculum we're analyzing today was actually built in the spirit of vibe rounds. It's a system that's completely focused on Socratic learning and guided discovery. It's really about asking the right questions rather than just getting handed the answers. So I want you to pause for a second, think about it. When you or maybe a loved one gets sick, how do you search for medical truth? What's your actual process for parsing through all that noise?
For most of us, that process starts with what clinicians call a vague clinical worry. You just start Googling messy symptoms, right? We've all been there. But let's put this in tech terms. A vague medical worry is basically a poorly formatted SQL query. It's just bad user input. And if you feed bad input into a massive database like PubMed, you're going to get garbage output, for sure. So we have to contrast that messy, unstructured panicking with the clean, highly targeted reality of an answerable clinical question.
Which brings us to part 2, PICO the search schema. So if our main problem is bad user input, we obviously need a rigorous framework to standardize it. And the crucial point here is that PICO is essentially the ultimate API query format for the medical literature database. It literally takes all the human complexity of a patient scenario and translates it into queryable, structured data variables. It perfectly bridges the gap between the patient at the center of the problem and the vast, frankly overwhelming ocean of clinical evidence. Let's actually break down this schema. PICO stands for Patient or Population, Intervention, Comparison, and Outcome. I want you to think of these exactly like parameters in a function. P is your target demographic. Who exactly are we talking about? I is the intervention. Maybe that's a new drug or a specific diagnostic test. C is your control group, which is often just standard care or a placebo. And finally, O is the outcome. That's the specific metric you want to measure, like reduced symptoms or lower risk. By just filling out these 4 variables, you've successfully turned a totally messy patient case into strict data variables. Pretty cool, right?
Moving on to part 3, matching questions to designs.
Now, what's really interesting about this step is that once you have a freshly built query, you have to make sure it hits the correct data architecture. And it is fascinating how perfectly clinical study designs map to concepts you probably already know in tech. Different queries require entirely different study designs. For example, if your question is about a therapy or treatment, the ideal design is a randomized controlled trial or an RCT. In the tech world, this is exactly what A/B testing is. Now, if you're looking at harm or prognosis, you're going to need a cohort or case control study, which is basically observational analytics. And for diagnosis, you'd look for a diagnostic test study, which is identical to classifier evaluation, where you're looking at sensitivity, specificity, and predictive values. But you have to be careful here. A huge takeaway from the course material is that you absolutely cannot use an RCT for long-term risks or rare harms. RCTs are incredibly powerful, yes, but they are completely the wrong tool for that specific job. It's exactly like software engineering. If you pick the wrong database for your specific application, it will inevitably lead to flawed data outputs. Okay, part 4, executing your PubMed search. Let's move to the execution phase and see how this all builds into a clean, algorithmic process. Step 1, you define those PICO variables we just talked about. Step 2, you identify your specific question type. Is it therapy, harm, diagnosis? Step 3, you match that question to the ideal study design. And then finally, step 4, you take all that nicely structured information and use it to build and run a real search in a massive database like PubMed. So just to quickly summarize our search execution flow, you always start with the patient at the center. Then you construct your PICO query to define the parameters. Next, you filter the medical literature by the matched study design. And finally, you execute. We aren't just blindly searching. We are systematically filtering down millions of papers to find the exact evidence we need using pure logic and structure. And that brings us to our final section, Part 5, the LLM Research Assistant.
Let's be real, we can't talk about searching complex databases today without talking about AI. The course includes this brilliant companion prompt library for using a large language model responsibly at every single stage of this workflow. You can basically use an LLM as your own personal clinical research assistant. It can help you formulate those tricky PICO questions, build out complex search strategies, and even screen incredibly dense abstracts. It's also fantastic for extracting trial methodologies and calculating complex metrics like absolute risk reduction, relative risk reduction, and number needed to treat.
And this brilliantly illustrates the absolute golden rule of LLM-assisted evidence-based medicine. Listen to this. The rule is simply, the LLM drafts, you verify every number and citation against the source. AI is a ridiculously powerful assistant for sure, but we all know it's prone to hallucinations. So, as a skeptic and a techie, your job is to independently validate those outputs. Think of this like a super strict division of labor. On one side, you have the AI's responsibilities, drafting the search strategies and extracting the methods to get you that initial first draft. On the other side, the human responsibilities. That means verifying every single number and checking all citations. This enforces a strict trust but verify mandate, which is absolutely critical when you're dealing with health and clinical evidence. So stepping back for a second, just look at the narrative arc we've covered today. We have successfully taken a really bad user input, that initial vague, panicked worry, structured it through PICO, matched it to the correct architectural design, and executed it to find verified evidence-based answers. The whole goal is to move from the patient to PICO to evidence safely and effectively. I want to leave you with a final thought to mull over. The next time you're doom scrolling through the news and you see one of those sensational, overly dramatic medical headlines claiming a miracle cure or maybe a terrifying new risk, how will you apply this PICO schema to test it? Because you now have the tools to break down that headline, define variables, check the study design, and find the actual truth behind the data. Keep practicing these text-translated skills and stay curious.